All right, so quiz 31, study guide. And problem number 1. Suppose W and T vary inversely. All right, so this is a problem that was on last week's quiz, but a bunch of people got it wrong because of simple multiplication. So if W and T vary inversely, that means W times T equals K. And you're told that T equals 1/5 when W equals 4. Write the function that models the inverse and find T when W equals 9. So if we multiply W times T, we get 1/5 times 4 equals K. So K equals 4/5. And then we said that if W times T is equal to K, and we're trying to find T, so if W times T equals K, and we're trying to find T, we divide each side by W. So T is equal to our constant, right, which we just found, 4/5, over W, all right? So we just put the W right here. And then you had to evaluate it when W equals 9. So if we're going to evaluate this for W equals 9, then T is equal to 4 over 5 times 9. So T is equal to 4 over 45 when W equals 9. All right, and then problem number 2 tells you, suppose that Y varies directly with X. All right, Y varies directly with X. That's Y over X. And inversely with Z. So Y times Z over X is equal to the constant. It says when Y equals 18, when X equals 15, and Z equals 5. So 18 times 5 divided by 15 equals 6. So our constant is 6. Write the equation that models the relationship. So if we're writing an equation that models this relationship, our Y times Z over X is equal to the constant, which is 6. Well, we're going to get the Y by itself, so we're going to multiply both sides by the reciprocal of this Z over X, which is X over Z. So on this left-hand side, these two X's cancel each other out, and so do these two Z's. So we're left with just the Y. So Y is equal to 6X over Z. There's your function. That's the equation that models the relationship. Then you're asked to find y when x equals 21. So y is going to equal 6 times 21 divided by z equals 7. So 21 times 6 is 126 divided by 7 should be 18. So 18. All right, here's your equation that models the relationship. And here's your y when your x is 21 and your z is 7. Any questions on either of those two? Problem number 3 is just a simplify problem. You got q squared plus 11q plus 24 divided by q squared minus 5q minus 24. All right, so we can rewrite the numerator as q plus 8 times q plus 3. Rewrite the denominator as q minus 8 times q plus 3. The q plus 3's cancel. We're left with q plus 8 over q minus 8. And our restrictions are that q cannot be equal to, right here, it can't be equal to positive 8. That would create a 0. And right here, it can't be equal to negative 3. So there's your simplest form with your restrictions. All right, problems 4 and 5. What is the product? State any restrictions. So problem number 4 here, we got 4a to the 5th over 7b to the 4th times 2b squared over 2a to the 4th. All right, so we've got an a in the denominator, a b in the denominator, so a cannot be equal to 0 and b cannot be equal to 0. So right off the bat, I'm going to cancel these 2's. This b to the 4th and b squared goes into itself once, and into b to the 4th, b squared times. A to the 4th goes into itself once, and it goes into a to the 5th, a times. And there's nothing left to cancel. So across the numerator, we got a 4 times an a times a 1, which is 4a. Across the denominator, we got 7 times b squared times 1, which is 7b squared. So there's your simplest form and your restrictions. Problem number 5, z squared over z plus 1 times z squared plus 3z plus 2 over z squared plus 3z. All right, so as far as restrictions go, z cannot be equal to, right here, it can't be equal to -1. And if we factor this other denominator, we can factor out a z times z plus 3. So this z by itself is a factor. So z cannot be equal to 0. And then this z plus 3 as a factor, z cannot be equal to -3. So we're going to factor this numerator to z plus 2 times z plus 1. And now we can start canceling. So z plus 1 cancels a z plus 1. A z down here on the bottom goes into itself once, and it goes into z squared, z times. And that's it. So in the numerator, we get z times z plus 2. In the denominator, we get z plus 3. All right, number 6. We're dividing now, so we got x plus 2 over x minus 1. Divided by x plus 4 over, and it's a trinomial, but I'm just going to factor it now. It's going to be x plus 5 times x minus 1. All right, so we talked about this yesterday, but again, get some restrictions now on both denominators. So we get x that cannot be equal to, right here it can't be equal to a positive 1. And right here x can't be equal to a -5. And we've already got this positive 1. So now I'm going to rewrite this. I'm going to flip this second fraction. So we get x plus 2 over x minus 1 times x plus 5 times x minus 1 over x plus 4. So get any more restrictions right now. We've already got the 1, but here we need a -4 as a restriction. So there's your third restriction. Not a whole lot of canceling, but these x minus 1s cancel each other out. We're left with x plus 2 times x plus 5 in the numerator, and just the x plus 4 in the denominator. So that's your simplest form with those 3 restrictions. All right, we got one more division problem to do. And I'm going to write it out in factored form. You can see the original form on the study guide that I posted. So we're going to get x plus 4 times x minus 4 over x plus 3 times x plus 2. We've got to divide that by x plus 4 times x plus 1 over x minus 4 times x plus 2. All right, so this is when you want to get your restrictions on all the denominators. So we would have a negative 3 here and a negative 2. In this factor, a positive 4 and another negative 2, so just a positive 4. So now, unfortunately, we're going to rewrite this thing. So x plus 4 times x minus 4 over x plus 3 times x plus 2 all of that being multiplied by x minus 4 times x plus 2, and our final denominator is the x plus 4 times x plus 1. So then let's get our second round of restrictions. Okay, right here, negative 3, we've already got it. And right here, the negative 2, we've already got it. Now, right here, so negative 4 would create a 0. So negative 4 becomes a restriction. And then right here, negative 1 plus 1 would be a 0. So there's your last one, negative 1. So 5 restrictions there. When you start canceling, I see an x plus 4 and an x plus 4. An x plus 2 with an x plus 2. And that's about it. So in the numerator, we get x minus 4 squared. In the denominator, x plus 3 times x plus 1. With those restrictions. Any questions on that study guide? All right, that completes your quiz 31 study guide.